Welcome in the section number 6 of our chapter about food preservation, safety, and quality management. After study of storage, characteristic of storage, preservation of technology, used existing technology, and development and under development technology. And the last section will talk about management, quality management, food preservation, and safety in general. And this last section number 6, we talk about enhancing food preservation throughout quality assurance, digitalization, and packaging innovation. Firstly, overview about quality assurance. We we introduce this section talking about the importance of quality assurance in Europe in general, covers regulatory, sensory, nutritional, and authenticity dimension. We talk about quality. There is physical, chemical quality. There is healthy quality. Asian quality, and there is a nutritional quality related to composition and nutrients for the product. PGU and PGE as introduction first part of this presentation systems enforce strict geographic and process related quality criteria specified for each region. Regulation 1169 developed in 2011 ensures transparency of labeling and builds consumer trust. Packaging and food contact rules prevent contamination and quality degradation. This framework ensures not only safety but also preservation of freshness and quality, such as sensory quality of the product, but also nutritional quality of finished product. About quality practice in industry level. European companies integrate audit certification and testing practice of routine operations. Shelf life monitoring ensures sensory and nutritional stability across the product life cycle with the after production of the product and his the dif in the and it depend of storage condition. Nutritional and compositional claims are validated throughout laboratory verification. However, for a sensory assessment, maintain consistency and test texture and aroma with some test with some follow-up of this analysis with the panel expert of analysis of sensory of each product for an laboratory in general to develop this and high quality product for consumer. Regulations drive continuous improvement and preservation, packaging, and logistics. About challenges of this quality assurance, a lot of challenges exist related to the product, but also to traceability of the product, of the historic of the product, such as such as the production, such as from raw materials, from agriculture part and chain, production chain, and then distribution chain before attend consumer. High costs of advanced testing create barriers for small and medium enterprises. Consumer expectations vary widely across European member states. Premier products require more and intensive preservation and monitoring systems. Enforcement of regulation differs slightly across national authorities. Logistics remain a major factor shaping product freshness and quality outcomes as presented in this cycle of quality assurance with the passing from identity issues with process, for example, and generate a correction actions. The with passing for verification, then implementation of corrective action. It's in a circle, and this circle we are talking about this circle for, when talking about HACCP or ISO to 22,000 with this assurance, this quality assurance and of management or system implemented in industry. Analytical test in Europe, European laboratory, but not just in European laboratory. We have some equipment specific for analysis of laboratory, specific for laboratory such as chromatographic analysis, but also spectroscopic analysis. For example, use HPLC, high pressure liquid chromatography, or GC-MS, gas chromatography, mass coupled with spectroscopy of spectroscopy. This technology is innovative technology, is quantitative but also qualitative technology, but also quantitative technology to detect, to characterization, to separate the compound, and this type of technology is used in a quality laboratory in general to analyze composition, chemical composition of different products, but also to detect some fraud as we talked about in previous section, some fraud to detection, some phytosanitary product, to detection some mycotoxin, to detect some undesirable ingredients in a compound, for example. Also, the spectroscopy and the microbiological assays that for the objective to get the product with high quality, high microbiological quality, but high chemistry quality. This method detects oxidation, spoilage markers, adulteration, and contaminants of different products, such as analysis of different products of milk, for example, to detect presence of some antibiotic, for example, in the milk, or for example, detection of fraud for honey, use of sugar rather than natural sugar presence of on the honey, to detect presence of glucose, fructose, and sucrose, for example. We use HPLC to detect presence of this market sugar of the honey, and then we verify if our meal or if our honey is of high qualities, authentic product or not. Another method, another technology, a new technology is Meter Food AI, harmonizes testing protocol between member states. It's analytical data validated modern preservation technology like HPP, pressure technology, and atmosphere modification, atmosphere technology, MAP, early presented. Early detection reduces corrective costs and prevent large-scale waste, and then ensure sensory but also nutritional quality of the product for consumer. Analytical testing challenges. It's in general, it depends of the costs. In general, it's expensive as technology for smaller companies. Method harmonization continues to differ slightly across European countries. Transition from periodic testing to real-time monitoring is difficult. And then some companies lack sufficient analytical expert to interpret complex data. Thus, it's very important question regarding formation of technician and engineer for this type of technology to ensure these responsibilities. Integration of analytical results into logistic systems. remain an operational challenge for this type of analysis and laboratory and get technical quality of the products. About sensory evaluation, sensory testing is identifies early declines in aroma, texture, and color. In general, is ISO 8586 standards ensure trained panel consistency across the region. The objective is organoleptic analysis of the product to define the attributes or criteria of texture, criteria of color, criteria of aroma, of flavor, criteria of firmness of the product, of consistency of the product. And all this information are explained in chemistry in chemistry level. For example, for texture, it depends of consistency of your product, and consistency of your product is, in general, is fiber, for example, such as pectins, such as polygalacturonic acids composition in your product. And for aroma, it's volatile composition, it's aroma composition that explained your the aroma. And for color in general is it related to presence or absence of pigmentation, such as carotenoid, beta carotene, or xanthophyll, or lycopene color range. That is very important as analysis to ensure quality of the product. Sensory data grid packaging, storage, and distribution strategies, sensory shelf life studies help refine realistic expiration dates. Differences in culture preference complicated sensory standardizations. It depends on the region, this question, but it's one of the main important analyses to evaluate the quality of the product. Nutritional quality. Nutrition analysis monitors regarding vitamins, antioxidant, and fatty acid during storage. In my laboratory, that is our specialty, it's nutritional quality with analysis of composition, nutrient analysis, composition, such as polyphenols, such as pigmentation, such as metabolite, primary metabolite, but also secondary metabolite. Non-thermal technology often preserve nutrient better than thermal method. Nutrient loss affect labeling accuracy and consumer value perception. Companies model nutrient degradation alongside microbial growth curve. Nutritional preservation is now a competitive advantage in European market. And this question of nutrition quality is very important for any industry, any laboratory, for example, for formulation of a new product, for example, for create a new solution with some product with some adjustment and composition of the product with some nutrient value, some nutrient quality, nutrient compounds, or to satisfaction of consumer demand in general, because the tendency is the use of bioactive compound, use of the vitamins, natural acids, natural antioxidant for the product as alternative to chemical compounds. And so nutritional quality is one of the most important side of the quality of the product quality. About the traceability and anti-fraud, as we talk about in the previous sections, traceability is in sort of creation of the historic of the product from production, agriculture part to consumer. You passed with the chain production. The fraud in origin and composition, certainty, quality, and trust. The European Food Fraud Network, as I indicated in the first and previous section, coordinated investigation across the region to detect this practice, this fraud practice in the industry and food industry. So the technologies such as blockchain and RFID enable transparency, traceability, scientific authentication, use DNA test, for example, or some isotopes and chemical fingerprints, for example. There is different application for this type of analysis, and that make analysis easily and rapidly and faster. Strong traceability reduces ancestry recalls and worst type of the product, and this is it's an important question as strong as getting strong traceability for each type of product of each type of industry is one of the principles of quality management systems. In this table, for example, that I included, we include some example of the technology of applied in general in industry and food industry regarding, for example, RFID. It's an radio technology, a blockchain technology, IoT sensors technology, DNA testing technology is the new technology developed and developed also with some research actually about this type of technology. Main function for RFID, for example, is batch identification, faster cold chain checks directly. For blockchain is immutable records and anti-fraud transparency. However, for IoT sensor condition monitoring, dynamic shelf life during storage of the product is one of the high technology developed for this type of for shelf life management. DNA testing is it practices for species origin for origin verification. It related to genetic and characterization of OGM, for example, or characterization of some species, no undesirable species in the product or an ingredient undesirable, and that it's one of the tool that use also on fraud prevention. Many traceability systems are still too costly for system of management in general because it's very expensive. Cross-border interoperability is a significant challenge for this type of technology. Data privacy rules restrict unstructured data sharing of all this for all this information. Some of this technology use is confidency for a supplier of the technology. Smart packaging ensures lot-level traceability. Dynamic shelf life becomes possible when a storage is fully traceable. A risk of governance in Europe, but in general, this question of preservation of food preservation and safety and quality management necessitate is and good governance. In Europe, if say provide scientific assessment, will RACFF manages rapid alerts, for example. SCOPEF coordinate policy and technical action among member states of Europe. About digital tools developed or under development regarding IoT sensor, for example, data with inspection for workflows. Risk of governance now includes spoilage and quality risks, not only safety. The One Health approach links human, animal, and environmental risk factors to create the synergical between different actors and transparency between different ingredients with high communication level to for this to get a high quality of services and products. About European risks assessment, in general, European flows and four-step risks assessment methodology, uh, predictive microbial models, estimated growth and inactivation under a variable condition. And this, it's one of the question of development of a new research, of a new technology application for modelization using softwares such as R softwares or MATLAB analysis modelization to develop some technology, some applied in field of food science and technology. EA-based modeling now chances spoilage for forecasting. For example, we use this application based on AI technology to modeling to modeling analysis application to avoid spoilage of food during production, during industrialization, but also during storage and in shelf life of an extended shelf life of the products. About exposure assessment help quantify potential water or return volumes. That is very important regarding the quantity and of the waste, and what that is one of the next chapter about the management of the waste product issued from food product or other type of industry, and how we can valorize this type of potential waste to get added value for different type of product. Modeling supports more efficient shelf life optimization strategies for this type of risk assessment applied in Europe. About methodological challenges in Europe in general related to food preservation, spoilage risk modeling is highly dependent on realistic environmental data, and it depends of the activity of each company, of each industry, and the existing technology that this industry applied. For this, one of the master challenge of the situation, the existing situation for any industry, diversify the microbe complicated predictive accuracy, for example, to detect the microbial, what type of microbial, this diversification of microbial is make work and challenge for this type of product, and it's one of the question of research for new application specific for a type of microbial analysis. Data sharing is limited across border and companies. After research, we don't found enough data, enough information about this companies, so we can develop a new application or new technology specified to each the problematic of each industry. About system of management, often lack the digital tools required for modeling, because with AI technology, with AI base, we can develop. There is development. There is some application under development, and we have a lot of there is a lot of idea to develop some digital tools. We explained some these tools in this chapter, but we have to explain other tools in the next chapters for to get more information about this importance of and advantage of digital tools for the industry, especially for food industry. Regulatory frameworks don't yet mandate spoilage modeling because this spoilage modeling the spoilage impact, it depends of nature of the product, it depends of the activity of enterprise, and we don't have enough data sharing with this lack of data about this type of spoilage. A regulatory framework don't intervene in analysis and in terms of application of measure specific for spoilage modeling. About crisis response, we developed the importance of this crisis, the management of crisis in the industry to preserve quality of the product, to management quality of the product from raw material to finished product. Is very important question for industry. European food crisis highlight the importance of rapid cross-border coordination between different actors of industry to create this synergical communication, transparency between all different actors of industry, and that's the base of success of the management of each system applicate for management and food preservation. A digital dashboard accelerate communication and corrective action. That is one of the usually used and the big companies use this type of communication, such as digital dashboard for to facilitate it or to make easy communication between different action. Crisis events often cause quality losses, even when safety remains intact, and the traceability systems enable targeted rather than large-scale recalls. That is one principle of different standards, different norms, and for quality, for high to get high quality traceability system, management of and traceability systems. A regular simulation exercise strengthen perhaps preparedness for this type of crisis response to get this this idea to management and possibility crisis for in future for each industry. About food system resilience, it's one of the important axes for industry, for Europe in general. Resilience of is foreign system is very important. From the COVID-19 crisis exposed the weaknesses in cold chain and logistic systems. There is differentiation before and after COVID-19. The situation is not the same regarding the use of raw materials, regarding the compartment, regarding the situation, regarding the cost, regarding the condition, regarding the production chain. There is a variation of all these factors, and that make an impact for food system resilience in general in Europe. Companies increasingly adopt enabled monitoring sensor technology to improve resilience that have different advantage to each enterprise to management of his services and quality of their product of his product. Predictive tools help anticipate spoilage during disruption, but also during storage of the product. These predictive tools make give the idea of the situation of your product and give you an estimated of the duration, for example, of conservation of your product and shelf life. Give this predictive tools. It's objective tools, not destructive tools that make the management easily. For example, for management of spoilage during storage. Resilience strategy reduce waste and protect produce quality, reduce waste with the valorization of this type of product, valorizing them in different product, in different idea, in different sectors, environmental sectors, for example, or medical sectors, or consumer sectors, or cosmetic sectors, or also for food product sectors. We can valorize the waste and use this ingredient, valorized ingredient for as ingredient for formulation of a new food product. Major challenges include climate stress, data interoperability, and just a management system capacity of each enterprise. About packaging policy framework, it's very interesting question regarding packaging policy, regulatory of the packaging. The PP where the PP requires all packaging to be recyclable by 2030. This question of recyclage of the packaging is one of the must question for any industry to respect the regulation and respect the quality of the product and consumer. The eco design regulation promotes materials with minimal environmental impact. There is all specification regarding this type of materials, and very important to use it dependent of nature of the product. Packaging influences preservation performance and overall waste level is an important. It's one of the actual question of nature of the packaging, material of packaging, and with nanotechnology that I'll use it for fabrication, formulation of this type of packaging. All this question influence the preservation of quality of the product during manufacture, during shelf life, and during storage of the product. Manufacturers must balance sustainability and barrier functionality. This very question as indicated between used intelligence packaging for specific for each type of products without impact his quality, and then the health of the consumer. Regulation accelerate innovation across packaging industry because it's very important. It's strict regulation regarding the production of this type of product, this type of packaging. Regulation is accelerate the recommendation, accelerate the articles regarding the use of packaging industry. Innovative packaging materials. In this table, we presented some emerging packaging materials with some characteristic, property, and benefit. For example, uh, different biopolymers are used for PLA, PHA, for example, or nanofiber films, cellulose coating, or this type of material we can use it them for are used for preparation formulation of the packaging. Each material have another advantage or have a characteristic for PLA. For example, bio-based polymer, compostable tris films. For PHE, high biodegradability, reduced plastic footprint. And for nanofiber films, higher barriers, longer shelf life for the product that needs extended shelf life product. Cellulose coating recycled, improved gas control for this type of materials. About this materials, in general, biopolymers replace fossil-based plastics in many food applications. That it's tendency for this type of to as alternative for this type of materials, and that's it's one of the question of transparency between consumer and manufacturers. Nanofiber technology improve oxygen and moisture barriers. Smart sensors are increasingly integrated into packaging films. Active systems realize antimicrobial or antioxidant on demand. Infrastructure for recycling or compositing remain even across Europe. All this alternative, all this active intelligence solution are developed. Other technologies are underdeveloped for this question of the packaging and principal crucial question for industry and especially for food industry production. A life cycle assessment of any of the product. LCA evaluates its environmental impact from production to disposal. And for food waste usually contribute more emission than packaging itself. It's really important. So it's really important to management this type of product, especially food waste of products. Slightly heavier packaging may benefit climate goals if it reduces storage for this type of packaging. That's one of advantage of this, or the main advantage of this type of packaging. European producers now include preservation performance in LCA comparisons. Packaging design is shifting toward the preservation and form development, and it's one of the question principle of traceability, because traceability of each product it indicated in general packaging of the product, and the among all information, among the composition material used for develop or for formulation of the packaging, there is this question of the information of consumers with indicated of traceability information of the product, such as the name of the product, market, origin, entreprise, consumer date, for example, DLC, or there is a lot of information that is very important to applicate it and traceability of the product. Smart active packaging is one of the solutions that and under development. TTS provide visible evidence of thermal exposures, freshness, and sensor monitor gases such as CO2 or oxygen or volatile amines, but that are used as a base for this type of sensor monitors. Antimicrobial packaging delays microbial growth. EUT connected packaging allows real-time monitoring, and logistic is one of the high technology developed which successfully in this type of activity for logistic. Standardization and compatibility remain key challenges for this type of packaging, especially smart active packaging. It about standardization in general in Europe, there is some lack about standardization of this type of new packaging, new solution, and but it's under development for to make it a solution for some problematic related to quality of the product. Digitalization overview about all this packaging as we presented. There is a lot of solution have developed and other under development. Digitalization transforms preservation drought real-time monitoring. Data allow companies to shift from fixed to dynamic shelf life. Transparency improve consumer trust and the market value of the product, and that it's the base, and that is the one of demand of consumers. Transparency of information about process of development of each product, his production, storage, shelf life, and it's one of law of for consumer to make transparency and that, trust for consumer. Waste is reduced due to better logistic and condition-based routing. Adoption remains uneven across uneven across the European food sector, and this is one of the must question of the must acts for this type of digitalization tools used for food preservation. EOT preservation and preservation, it's a tool, excellent tool that developed for management of preservation, food preservation, business, the sensors, track temperature, humidity, choke, and gas level. Early alert prevents sealant cold chain failure. Remaining shelf life can be calculated based on the real storage history, and smart logistic route, stronger batch to longer markets. Different advantages for this type of technology, of this type of application developed for industry, and the data integration across partners remain one of the largest bottlenecks. That is one of the high excellent technology developed and other underdeveloped for some other application for preservation, food preservation, and quality management of foods. Blockchain applications. Blockchain provide tamper-proof records for product history. As I mentioned before, consumer-facing QR code, for example, ensures transparency about traceability of the product, the historic of the product, using this a QR code or barcode for indicated in the packaging of the product, that give the idea of trust, of transparency between manufacturers and consumer. Targeted recalls reduce waste and financial losses. This is one of the benefit or advantage of blockchain application. Fraud detection become more robust with immutable data. That is very important question and success for the use of a new technology such as spectroscopy technology or chromatography technology to detect the fraud and composition of the food, but also detected the fraud using this application like a blockchain. challenges include cost, interoperability, and governance. It's one of the most challenges of the use of this AI tools, of the use of this technology, innovative tools. It's the cost. Big enterprise can use this technology, but uh, for smaller companies, it's a challenge regarding the cost, expensive tool cost, and the probability for governance. We if Even if we don't have formation about this type of tools, or there's not we don't have, and lack of human technician or engineer to management of these tools in industry. Role of AI is very important to indicate the AI models predicted microbial growth, oxidation, spoilage, timelines. There is a technology developed and used with bigger companies, but other applications are in development of for this type of technology. Dynamic shelf life modeling replaces rigid expiration dates. Vision systems grant fresh producer automatically. AI improve for forecast and reduce overproduction. The advantage of the AI and the food preservation and quality management is very diverse, is very high, it's very important in different slide, from slide of production agriculture to side of production chain industry. There's different application that we use for detection for different step as alternative for step different company and companies, but also for distribution and quality management of the product. But we use this AI application, but also the challenge is the cost of this type of application, especially for smaller companies. AI improve forecasting and reduce overproduction. Compliance and data privacy remain key challenge of this type of technology, because of use of this type of technology implique the use of step of new materials for processing for each product. About opportunities, the digital systems on this table included the opportunity, impact for each technology regarding condition, base shelf life of the product, with the impact less waste, but better freshness, for example, predictive maintenance, give an impact and fewer refrigeration failure, supply chain optimization, lower spoilage during transport, and circular economic linkage, better byproduct utilization and valorization of the product waste. Digital solution unlock major efficiency gains for producers. Companies can optimize shelf life according to real condition, use this type of application for the management of their product. Predictive analyticals help prevent major equipment failure. Transparency increases consumer confidence and brand value. Integration across sectors ensures sustainability outcomes of this new digital systems. It all the benefit and advantage opportunities for agri-food industry. Dairy sector, as example, the dairy sector relies heavily on strict cold chain control. EOT sensors measures temperature and tanks, trucks and storage. AI and predictive analytical optimizes quality and inventory rotation at ACCP and ISO thousand remain essential foundation for management, quality management in industry, and especially for agri-food industry. Digitalization improves safety, quality, and waste reduction simultaneously. All this application are advantageable for industry and make progress, make benefit for any type of product development. About digital dairy application, ENN modeling, for example, as technology can accurately forecast shelf life and quality partners, is one of the tool under development and not early developed in stage pilot production industry. After analysis of documentation, data that data integration improves efficiency from farm to processing plant. Europe in the early 4.0 project automates milking and monitoring. That is some application. Digital signals help detect early deviation in fermentation and shearing. Sustainability benefit arrays, drought, reduced energy use, and waste. All this is advantage and benefit for this type of industry. Meat processing sector, this technology have a lot of objectives regarding high pressure technology. Pressure technology is widely used in Europe to preserve meat without heavy heating that deteriorate the composition of composition of, for example, of nutrients and meat, for example, protein, for example, some vitamins, some other product regarding heavy metals, or there is a lot of ingredients, benefit ingredients in the meat, but with heating, we degrade, we deteriorate this type of ingredients. So use high pressure technology is one of the solutions for this type of industry. It inactivated pathogens while retaining sensory quality. RTA meats benefit from post-packaging pressure treatment, modified atmosphere, MPA, improve oxygen control. Digital sensors help detect deviation and refrigerated transport. All this technology are a new technology developed and underdeveloped to application and mass production or pilot production. HPP performance significantly extended shelf life dependent on product type. Active packaging reduce oxidative acidity in the meat produces. Gas sensor detect leaks or oxygen ingress. Predictive tools forecast spoilage after temperature explosion during storage. Environmental impact depend on balance between energy and waste reduction, and that is one of the title for the next chapter about the management of the waste reduction and of the waste and type of valorization of this type of products. Smart packaging seafood is one, as we introduce in the in previous section, is one of the high solution developed. Northern Europe leads the development of biodegradable smart packaging. TTS are widely used for as packaging, smart packaging widely used for seafood logistics to evaluate cold chain integrity. Biosensor detects spoilage related volatile such as TMA. Code connected packaging enables action during transport. Trees show reduced spoilage related returns in high value seafood. About practical learning exercise, and there is some exercise related to practical part, as I mentioned, learning about application and situation and different situation. Some exercise are integrated in the practical part, and the other and the report and the main base document. This exercise, the objective is to learn and applicate all this notion, all this principle, all this technology, and have more information about this new technology and how use it then for application on niveau and in industry levels. Learners can build HACCP flow chart, including digital monitoring, sensory and chemical analysis, compare different preservation technology. Based on this part, practical exercise include and practical part, but also and document-based document of chapter. LCA exercise highlight the sustainability trade-offs in packaging, traceability, simultaneous simulation teach student how IoT technology and blockchain interact. This activity integrate safety, quality, preservation during storage, and sustainability of the product. Overall, synthesis of the chapter about food preservation, safety, and the quality management sections reveals how storage technique the sections, all the study sections reveals how storage technique, quality, preservation, and digitalization are deeply interconnected. Europe combines strong regulatory framework with rapid technological innovation, smart packaging, and AI push preservation toward the real-time condition-based models. The case studies from dairy and meat sectors show successfully industrial applications strategies for food preservation. And that is all for this chapters for this last section. And thank you for your follow-up for all sections. Thank you.